Find the derivative of y equals g of x over f of x, then evaluate y prime of -2, where we have that information there. Y here is the quotient of two functions, g of x divided by or over f of x. Both of the functions are unknown, but since we have a quotient of them, we can use the quotient rule for the derivative. The derivative y prime, or dy dx, is equal to the derivative of the numerator, we will call that g prime of x, times the denominator left alone, f of x, minus the numerator left alone, g of x, times the derivative of the denominator, we will call that f prime of x, and then that entire thing over the denominator, f of x squared. There's our derivative y prime or dy dx. The next thing to do is to evaluate y prime of -2. And that means to plug in -2 in for each of the x's. So we'll have g prime of -2 times f of -2 minus g of -2 times f prime of -2. And this entire thing over f of -2 quantity squared. G prime of -2 is a -7 according to the information that we have over here. F of -2 is a 1/2 according to that information. Minus g of -2 is a 4. And f prime of -2 is a -3/2. And then this entire thing is divided by f of -2, which is a 1/2 quantity squared. So y prime of -2 will be, in the numerator, we have a -7 times a 1/2. We can think of that as -7 over 1. -7 times the 1 is -7 over 2. And then we have a 4 times a -3/2. 4 times the -3 is -12 over 2. And that's being subtracted. And this entire thing over 1/2 squared. Now we squared the numerator of the 1/2. 1 squared is 1 over 2 squared, which is 4. Back in the numerator, we have a -7/2 plus a 12/2 all over 1 over 4. The numerator's fractions are already over a common denominator. We can combine them. 12 minus 7 is a 5. So we have a 5/2 over a 1/4. At this point, we're going to reciprocate the denominator fraction and multiply it with the numerator fraction. So we will have 5 over 2 times 4 over 1. 5 times 4 is 20. 2 times 1 is 2. Let's reduce that by a 2. And we end up with 10.